your curves here are, this is x cos alpha, this is alpha here, x cos alpha minus y sin alpha, y sin alpha minus b whole square, is it whole square? Sorry, whole cube. I'm sorry, this is whole cube is equal to c into x sin alpha, c into x sin alpha plus y cos alpha whole square. All right, whole square. This is the equation here. This is x cos alpha minus y sin alpha minus b whole cube equal to c into x sin alpha plus y cos alpha whole square. Okay, for all values of alpha has a cusp. It will have a cusp so that all the cusps lie on a circle. So it will represent a cusp for all values of this equation. We will just find out that what are the points here, and those the points are representing a cusp or not, that we will prove. And the path of the or locus of that cusp, okay, the double points, will be a circle. That also we have to show that all the cusps lie on a circle. This also we have to prove. This is the cusp we have to first prove, and then prove that the path of the or locus of the double point will be a circle. Second point. And second, first we have to prove that all these points will be a cusp. Means the condition which we will just find out, that will be representing in all the three conditions, whatever the points we will obtain, what that point is. Let me check. Okay. Question 13. Now let us find the solution of this. Solution. So to find out the double points, what we case that fx by, we consider the given equation as a function. Let us take this as x cos alpha minus y sin alpha minus b whole cube minus sin. Take this to the side. This is c into x sin alpha plus y cos alpha whole square. This is the whole square here, equal to 0. This is first equation of the curve given. We consider this as the first. Okay, so differentiating with respect to x by partially differentiating. Partial differentiation, applying partial differentiation. Applying partial differentiation, we get, what do we get here? Del f upon del x is equal to 3 will come here. This is 3 into x cos alpha minus y sin alpha minus b whole square left over. Again, this is to be differentiated. Now here only this x is differentiated, so cos alpha will multiply. We multiply this whole equation by cos alpha. Now second step is this, minus sign c as it is, whole square. So this is twice c, 2 will come before. This is x sin alpha plus y cos alpha. This is whole square is now left out. Now this again differentiate because it is a function of a function. We have to differentiate the bracket value again. This x is 1 sin alpha. We have to multiply by sin alpha. Coefficient of x here sin alpha. So we have to multiply by sin alpha. Okay, this is value of del f del x. This is, let me take second equation. Now del f upon del y, if I solve it further, so twice will be 6 here. This is x cos alpha. Sorry, what I'm doing here. Yeah. Sorry, this equation is to be differentiated. I'm sorry. Del f upon del y, we have to differentiate the first equation only, this one. It will again give us 3 into x cos alpha minus y sin alpha minus b whole square. Now this y sin alpha is again differentiated. It will be negative minus sin alpha here, sin alpha. Y is 1. We have to multiply by coefficient of y here, which is minus sin alpha, so minus into sin alpha. This is to be differentiated. So this is minus sin twice c again. This is minus twice c. Okay, and into x sin alpha plus y cos alpha whole square root, sorry, square is now 1 power, and this is the function, so this is cos alpha, multiply it by cos alpha, because coefficient of y here, negative positive, okay, because this is negative sign here, minus by sign, alpha's negative sign is there, this is minus sign alpha, but it is here positive, so plus cos alpha, but minus sign is there, okay. This is del f of del y, this is third equation, let me take. If I find out double derivative, del square f upon del x square, to be differences 2 3 6, now this is to be differentiated, so 6 into x cos alpha minus by sin alpha minus b whole square is now cancelled out, cos alpha is there, again this cos alpha will come, so this is cos square alpha, the value of this is, because differentiating with respect to x again, and this second step is minus twice c sin alpha into x, this value, only this will come out as, if I separate them, this will be constant, considered as constant, this second step, only this is because this is having x only. This is to be differentiated, this is minus twice c into sin square alpha, minus twice c sin square alpha, this sin alpha into sin square alpha, x twice c into x is 1, but this equation will be, this will be 0 because this is by sin alpha cos alpha and 2c constant, all are constants, only this is double derivative of x here. So this is double derivative. And let me take fourth equation. Now del square f upon del y square. This is del f del y here. This equation is to be again differentiated. It will be 3 to the 6 minus 6 x cos alpha minus by sin alpha minus b whole square cancelled out. Sin alpha is there, but this minus sin alpha again will come out. So differentiating this again, so by is 1 minus sin, so this is plus sin square alpha only, plus sin square alpha. This second step is to be differentiated again, so this minus sin, again this by sign is there, cos square alpha, okay, 2c, so this is minus twice c, by is 1 cos square alpha. This is the fifth one. Okay, now we have to find out the double points. So finding the double points, we have to equate del f upon del x equal to 0, or put del f upon del x equal to 0, and del f del y equal to 0, and f equal to 0. Okay, so for finding the double points, okay, del f upon del x equal to 0, del f upon del y equal to 0, and f equal to 0, these 2 points. Now if I equate del f del x equal to 0, this value, second equation, okay, so these two are the equations, let me write those equations, and this is also 0, so these two are similar type of equations. What do we do? Let me then solve those 2 equations. Okay, so let me solve those 2 equations. What we have to do, because this is equal to 0, this is also equal to 0, let me write here, equal to 0. This is 0, and this is also 0. Okay, then at the required point, what is the point we have to first find out, then we will find out the path, that what is the path or locus of the double points, and that double point will represent a cusp or not a cusp, that we have to prove. Okay, now if I solve this equation and this simultaneously, because we have to find out the x value, x easily cannot be calculated, what we do, we have to multiply this first equation by sin alpha, this by cos alpha, this sin alpha cos alpha will be same, then these two are to be added up, multiplying first by sin alpha, and second by sin alpha, and third by cos alpha. So we get, and adding both, and on addition, what we will get, these two terms on addition, because this is negative, this is positive, these two terms will be cancelled, because sin alpha cos alpha, this will be also sin alpha cos alpha, because this we have multiplied by cos, third by cos alpha, and first by sin alpha. This is sin alpha cos alpha, and this step is sin alpha cos alpha. This is negative, this positive. These two will be cancelled out. Only the last steps, for this will be sin square alpha, this will be cos square alpha. If these are the two on addition, sign are same, the terms are also same, so these two are added up, sin square alpha, sorry, this will minus twice c only into this. That means x cos alpha plus y sin alpha by cos alpha, sorry, x sin alpha plus y cos alpha equal to 0. It will give us, because these two are added up, sin square alpha plus cos square alpha, because this will be sin square alpha, it will be cos square alpha. Okay, I'm sorry, which one? This part. It will be sin square alpha, it will be cos square alpha. These two are added up. Sin square plus cos square alpha is 1. So these two are, if add, not add, but 1 minus 2c we will take common. So it will be x sin alpha plus y cos alpha equal to 0. This is the sixth equation that we take. And second condition. Now if I add them, so if I multiply the first by cos, second by third, and then subtract second from first one, this was addition, you subtract second from this, third from second, and now multiplying second by cos alpha and third by sin alpha, we get, subtracting third from second, and on subtraction of third from second, we get, so what do we get? Second question. In this case, if I multiply this by sin alpha, first one by sin alpha, sorry, multiplying first by cos alpha, which one? This one. First by cos alpha, second by sin alpha. This is cos square alpha. It will be sin square alpha. And if I subtract this from first one, this will be positive, this will be plus sign. Both will be added up. Sin square alpha cos alpha is 1. Only this value, and these two are cancelled out. Why? Third step, this is sin alpha and cos alpha, this is cos alpha sin alpha. These two steps are similar. If I subtract this from first one, this will be positive, this will be plus sign, this will be negative. These two will be cancelled out. Only this first one and the third one. These two are similar sign, because if I subtract this will be plus sign, so plus plus. These are added up, same similar sign. But here sin square alpha cos alpha is 1. So value will be 3 only, but this term equal to 0. It will give us, on addition, we get here x cos alpha minus y sin alpha minus b whole square. This is 3 times also, plus 3 times, equal to 0. Because these two terms, other term will be cancelled out, so it will be 0. What do we get here? This is nothing but x cos alpha minus y sin alpha equal to b here. So these two equations, first was this one, second this one. If I solve these two equations, let me solve them. Okay, then these two values, third also we have to find out. Del square f on del x del y, that also we have to calculate. Okay, this is del f upon del y, we have cancelled out. No problem, that we can do. Again we can do that. So that will be del square f on del x. These two terms we have put here. Now let me solve these two equations. What are those two equations? First is this x sin alpha plus by cos alpha equal to 0. And second is x cos alpha minus by sin alpha. This is cos alpha here is equal to b. Okay. Now if I multiply first by cos alpha, okay, and second by sin alpha. This is by sin or this is by cos, that doesn't matter. Let me multiply the first, this is first equation, first and this is second. Let me take these two equations we have obtained. Now solving for x and y, let me check whether what are the values of x and y here. So multiplying first by, let me find out first x. So for x, if this is to be multiplied by sin alpha, let me multiply by sin alpha. And second here, this is first and second y cos alpha. So what do we get from this? This x sin square alpha. This is plus y sin alpha cos alpha. Sorry, by sin alpha cos alpha, I'm sorry, equal to 0. This multiplied by cos alpha, second by cos alpha, this is x cos square alpha. Okay, minus sin by sin alpha into cos alpha. And if I equal to b into this cos alpha, b into cos alpha. Now if I add them on addition, this is plus, these two are cancelled out, same negative sign, positive sign cancelled out. This is b cos alpha. It will be x common, sin square alpha plus cos square alpha is 1 equal to b cos alpha. Sorry, b cos alpha. So x equal to here, this is 1, x equal to b cos alpha. X equal to b cos alpha. If I substitute this value in the first equation, this one, x equal to b cos alpha, this one here, so y can be then calculated from first equation. Let me check what is the value of y then. So from first equation, now let me write here. Okay, so these two values, this was value of del f del y, this was value of del f del x. This is del f del x, and this is del f del y. But we have to find out del square f upon del x del y also. This is to be differentiated again with respect to x. Okay, that is required because you have to prove whether this is representing a cusp. That means del square f upon del x del y whole square is equal to, it must be equal to del square f upon del x square into del x square f upon del y square. This must be satisfied. Only then it will represent a cusp. Okay, we are calculating value of x and y. X here we have obtained. Let me write it here. No problem. Above, let me write it down. So here x is obtained as b cos alpha. This is b into cos alpha. No problem. If I substitute this value in the first equation, which is this one, so x is, this is b cos alpha in place of x sin alpha, so into sin alpha plus by cos alpha equal to 0. Now y is equal to, therefore, negative this upon cos alpha. Cos alpha cancel out. It will be minus sin b sin alpha. Okay, this is value of y. The point is this b cos alpha minus b sin alpha. These are 2 points here. Okay, so let me now use this double point. Now at this double point, what the position of the curve given? Is it satisfied? So what do we get the point? This is x was b, from there y is minus b sin alpha, x is b cos alpha. It is b cos alpha and this is b sin alpha. Okay, now what we have obtained. Now if I okay, these are the two values, x equal to this b cos alpha and y equal to b sin alpha. Now if I square them, remove alpha, removing alpha because we have to find out the path here. So removing alpha here. On removal of alpha, removal of alpha, squaring and adding these two. On squaring and adding the two values of x and y. What do we get? So we will obtain here this x square plus y square, left hand side are added up, x square plus y square will be equal to, this is b square cos square alpha plus b square sin square. So b square is common. It will be sin square alpha plus cos square alpha, which is 1. So this is nothing but b square into 1. So this is equation of a circle. X square plus y square equal to b square, which represents a circle. So the path of the equation, double point, this is a double point here. We'll check whether this is satisfying the equation given or not. That will satisfy because this is the only point here. So this is, if I substitute x equal to b cos alpha, this is b cos square alpha, and this is y is b sin square, so minus b sin square alpha. This is positive. Okay, so this is positive sets, some value is given. Here equal to c into x is b cos alpha sin alpha, and this is plus b, y is b sin alpha cos alpha whole square. So this is given here, possible. Okay, so because this equation is satisfied then, because x value and y value if I substitute here in this equation given of the given equation of the curve, then it must be satisfied. So it is satisfying then. So this is the point here, x cos alpha, b cos alpha, b sin alpha, the 2 points here. Now for negative, one was negative here, y is minus b, y is minus b here, y is minus b. So this y is minus b here, minus b sin alpha. So then it will give us the same value. If I substitute these values there, x and y, here also x and y, and this is minus b whole cube. So will give us the equal signs. Okay, this equation will be satisfied then. But from this is cos square alpha, so this is b square, and this is minus b, b only, b into, okay, this is giving us b cube, minus b cancel out, this is 0, this is also 0, it will give us 0. How? Let me check it. So if I check this point by substituting this value of the equation, now this circle has been proved that the path of the locus of this point is the same. Okay, so now if I substitute this equation, this must be satisfied. X is b cos alpha, it will be b cos square alpha, minus sign, this is y positive because minus b sin alpha is there. This plus b sin square alpha, minus b whole cube, this is 0 here, this is b common from these two, this is sin square alpha cos alpha is 1, b minus b is 0, this is 0 here. The right hand side, this is c into x is here b cos alpha, so this is b sin alpha cos alpha, and this is negative y value minus b sin alpha. Okay, so both are cancelled out again, minus b sin alpha cos alpha. So this is also satisfied, this 0, so 0 equal to 0. Hence the equation is satisfied by this double point. The point is here b cos alpha minus b sin alpha. This is double point. Now is it a cusp or a node or a conjugate point, that we have to now prove here. Now let me take what is the value of del f, del square f on del y or del x at the given point. Okay, so if they are satisfied, then we can say that yes, they are the values. So these equations can be calculated, the values must be same. What are those same values here? Okay, so if I just find del square f from del x square, where it was, this value was there, 6 minus this. This is the value of, I think, del square f on del x square, the 51. This is del square f on del y square, and this was value of del square f on del x square, this value. And this is of del square f on del y square. This is plus 6, and here it is also, I think, plus 6 only. 6 value is there. So these two equations are to be solved. Okay, this multiply, I mean, at the point given x cos alpha, x b cos alpha, this is b minus plus b sin alpha. This is 0 here because this will be 0. Only these two, this value is obtained. Okay, so this is therefore del square f upon, let me write del x square equal to only this, because this is 0, just satisfied. After substituting this value, it will also be 0. This is 0 here, only this term is left over. Here it is minus 2 c sin square alpha at the point this b cos alpha and minus b sin alpha. Okay, at these 2 points, at this point this value is left over only because here this is 0, this we have just proved, and this is also 0 in the second case. And del square f upon del y square at the point this will be this value, which is minus twice c into cos square alpha. If I multiply these two minus plus, it is positive 4c square into sin square alpha into cos square alpha. This is value of del square f upon del x square into del square f upon del y square. This value is 4c square multiplying these two values. Okay, so we have obtained this 4c square and this. Now we have to find out what is del f upon del y. This was del f upon del y value, third equation. If I differentiate it with respect to y, okay, so let me do that. Sorry, with respect to x again. So these two values are calculated. Let me differentiate the third equation to find out del square f upon del x del y. This is the value of del f upon del y, this value. Okay, this is, sorry, minus sign, this value. If I find out this with respect to x, this is 6 here into this term is there. This is x cos alpha minus y sin alpha minus b here, twice has come before, into sin alpha. This is cos alpha again will come out because here x into cos alpha is there. This is sin alpha into cos alpha. This is sin alpha into cos alpha. First step. What about second, this one? It will be with respect to x only. This term, first one will be there. This is minus twice c. X is 1, sin alpha cos alpha. This is sin alpha into cos alpha. Only these two terms are there. Now if I substitute this value, okay, and if I substitute the value at the point, given point, what is that point? B cos alpha minus b sin alpha. This is value of y negative minus b sin alpha, and value of x is b cos alpha. If I substitute this value in this equation, del square f upon del x del y can be obtained. So now this equation is 0. Why? If I substitute x is b cos alpha, this is b cos square alpha. This will be positive b sin square alpha, b common, b positive and minus b 0, so it is 0. The first step is 0. Only this value will be left over. It will give us minus twice c into sin alpha into cos alpha. Try to understand. Now squaring this. So square of this del square f upon del x del y whole square will give us 4c square of this whole square of this whole, this one, will give us 4c square into sin square alpha into cos square alpha, which is the same value, 4c square sin square alpha into cos square alpha. This is the value of del f. So this implies that, what does it mean? That means the two values are same. What is that value? This implies that, what do we see? Del square f upon del x del y whole square is equal to del square f upon del x square into del square f upon del y square. Now these two values are, this value, whole square of this. This is 4c square into sin square alpha into cos square alpha. And from this multiplex of these two values, minus 2c cos square alpha and 2c sin square alpha, this one, multiplying the same values obtained here, 4c square into sin square alpha into cos square alpha. What does it mean? These two values are same. It means it will be a cusp. So it will represent a cusp. All the possibilities, the z double point which is here will represent a cusp only. Okay. The variety of this, so that the each of the curve this and this for all values of alpha has a cusp. It is a cusp now. So that all the cusps lie on a circle. On a circle that we have already removed. Okay, from values of this x and y, x equal to be at b cos alpha and y was minus b sin alpha. So squaring and this, so squaring and adding these two, we obtained already x square by square, adding, then so this will give us b here, squaring, so b square here, common, sin square by cos square is 1. This already we have proved. This is 1 here, so this is b square, x square plus y square is equal to b square, which is the equation of a circle, which we have already proved. So hence, this is representing a circle. So it will, because these two values are equal, in case of equal, the tangents will be real and equal. Tangents will be real and equal. Sorry, coincident or equal maybe. Coincident. So tangents will be real and coincident. That means it will represent a cusp. Hence, the double point. Hence, the double point. This one will represent a cusp. Okay, hence proved. This is how we have to prove these kind of questions. Some questions are more, because students have asked me some more questions. So if I write those questions here, again solve, same process there, though that will be illustrated further. So further illustration of singular points or multiple points are discussed in the next lecture series. In that we will discuss again further singular point and points of inflection. Okay, then curve tracing of the curve, how to trace a curve. After that, quadratures. Okay, finding the solution of many areas and volumes of the okay, these figures. So that is the process here. I'll take next some more points, the 13 or 12 questions again, because there are more questions of the students that also have to reply here. Okay, so those questions are to be taken in the next lecture series, so that this everything, the how to find out cusp, node, or a conjugate point, is it a conjugate point, or is it a node, or is it a cusp, that is simply we have verified here. We find out the function given, we assume that del f del x, we find out del f del y, we find out equal to, and then equal to 0 to solve the, to find the points, double points, and what the quality of double points, whether those